Hello and welcome to another lesson in chemistry. This week we're looking at stoichiometry again, specifically stoichiometric calculations, limiting reactants, and percent yield. I suggest you do the following while watching this video. Follow along in the book. The chapter and section numbers are at the top of the slides. Pause the video when necessary to find your place in the book, to listen again to something you didn't understand, or to work on one of the example problems. Reviewing from last time, a mole ratio is a ratio between the numbers of moles of any two substances in a balanced equation. The number of mole ratios that can be written for any equation is n times n minus 1, where n is the number of species in the chemical reaction. All stoichiometric calculations begin with a balanced chemical equation. Steps to solve mole to mass, and mass to mass stoichiometric problems. First step. Write a balanced equation for the reaction. Second step, determine where to start your calculations by noting the unit of the given substance. If mass in grams of a given substance is the starting unit, you must first convert to moles. If the amount of the given substance is in moles already, convert moles of the given substance to moles of the unknown. Step 3, the end point of the calculation depends on the desired unit of the unknown substance. If the answer must be in moles, stop, you're finished. If the answer must be in grams, convert moles of unknown to grams of unknown using the molar mass as the conversion factor. Here's an example. The carbon dioxide exhaled by astronauts can be removed from a spacecraft by reacting with lithium hydroxide as follows. Carbon dioxide reacts with lithium hydroxide to produce lithium carbonate. An average person exhales about 20 moles of carbon dioxide per day. How many moles of lithium hydroxide would be required to maintain 2 astronauts in a spacecraft for 3 days? Okay, first step is to balance the equation. In order to do this, a 2 is needed before the lithium hydroxide. Step 2, determine the moles of given substance. Okay, there's 20 moles per person. There's 2 people. That makes it 40 moles. Times 3 days equals 120 moles of carbon dioxide. 3. Convert moles of given substance to moles of the unknown. In this chemical equation, we know the carbon dioxide. Okay? We're being asked to calculate the lithium hydroxide. So therefore, we would take the 120 moles of carbon dioxide, multiplied by the mole ratio, 2 moles over 1 mole. We get this from the balanced equation. If you look above, there are 2 moles of lithium hydroxide required for every 1 mole of carbon dioxide in the reaction. So 2 moles over 1 mole gives us 240 moles of lithium hydroxide. Why do reactions stop? Reactions proceed until one of the reactants is used up and one is left in excess. Very rare, in most cases, that the amounts would be exactly exactly the amount of each reactant to go to completion. Usually one is left over. The limiting reactant limits the extent of the reaction and thereby determines the amount of product formed. The excess reactants are all the leftover unused reactants. Determining the limiting reactant is important because the amount of product formed depends on this reactant. So we can calculate the product or the amount of a product when a reactant is limited. So for instance, we have an equation here, S8, which is liquid sulfur, plus 4 moles of chlorine gas, gives us 4 moles of disulfur dichloride. If 200 grams of sulfur reacts with 100 grams of chlorine, what mass of disulfur dichloride is produced? Now, one of these, given that this is a problem, a limiting reactant problem, one of these, either the 200 grams of sulfur or the 100 grams of chlorine, are going to be the limiting reactant. So the first step is to determine the moles. 100 grams of chlorine times 1 mole of chlorine over 70.91 grams of chlorine yields 1.410 moles of chlorine. 200 grams of sulfur times 1 mole of sulfur over 256.5 grams of sulfur equals 0.7797 moles of sulfur. Step 2. Determine whether the two reactants are in the correct mole ratio as given in the balanced chemical equation. Only 1.808 moles of chlorine is available for every 1 mole of sulfur, instead of the 4 moles of chlorine required by the balanced chemical equation. Thus, chlorine is the limiting reactant. Calculate the amount of product formed based on chlorine. 1.410 moles of chlorine times 4 moles of disulfur dichloride over 4 moles of chlorine times 135 grams of disulfur dichlorine per 1 mole of disulfur dichloride yields 190.4 grams of disulfur dichloride. Now that you've determined the limiting reactant and the amount of product formed, what about the excess reactant, sulfur? How much is reacted? You need to make a mole to mass calculation to determine the mass of sulfur needed to react completely with 1.410 moles of chlorine. 1.410 moles of chlorine times 1 mole of sulfur over 4 moles of chlorine from the balanced equation equals 0.3525 moles of sulfur. Then we're going to now convert that into the mass, where we take 0.3525 moles of sulfur from the last calculation, multiply it by the molar mass of sulfur, 265.5 grams over 1 mole of sulfur, and we find out that with the amount of chlorine available, we would use 90.42 grams of sulfur. Knowing that 200 grams of sulfur is available and only 90.42 grams is needed, you can calculate the amount of sulfur left unreacted when the reaction ends by subtracting 90.42 grams of sulfur from the 200.0 grams available, and showing that there will be 109.6 grams of sulfur left over when the reaction is over. Calculating the product when a reactant is limiting. Using an excess reactant can speed up the reaction. Using an excess reactant can drive a reaction to completion. How much product? Laboratory reactions do not always produce the calculated amount of products. Reactants stick to containers. Competing reactants form other products, or competing reactions form other products. The theoretical yield is the maximum amount of product that can be produced from a given amount of reaction. And it's theoretical. It's on paper. It's calculated on paper. The actual yield is the actual amount of product produced when the chemical reaction is carried out in an experiment. The percent yield of a product is the ratio of the actual yield expressed as a percent. So percent yield is equal to the actual yield over the theoretical yield times 100. Percent yield is important in the cost effectiveness of many industrial manufacturing processes. Okay, the key concepts we went over. Balanced chemical equations can be interpreted in terms of moles, mass, and representative particles. The law of conservation of mass applies to all chemical reactions. Mole ratios are derived from the coefficients of a balanced chemical equation. Each mole ratio relates the number of moles of one reactant or product to the number of moles of another reactant or product in the chemical reaction. Chemists use stoichiometric calculations to predict the amounts of reactants used and products formed in specific reactions. The first step in solving stoichiometric problems is writing the balanced chemical equation. Mole ratios derived from the balanced chemical equation are used in stoichiometric calculations. Stoichiometric problems make use of mole ratios to convert between mass and moles. The limiting reactant is the reactant that is completely consumed during chemical process. Reactants that remain after the reaction stops are called excess reactants. To determine the limiting reactant, the actual mole ratio of the available reactants must be compared with the mole ratio of the reactants obtained from the coefficients in the balanced chemical equation. Stoichiometric calculations must be based on the limiting reactant. The theoretical yield of a chemical reaction is the maximum amount of a product that can be produced from a given amount of reactant. Theoretical yield is calculated from the balanced chemical equation. The actual yield is the amount of a product produced. Actual yield must be obtained through actual experiments. Percent yield is the ratio of actual yield to theoretical yield expressed as percent. High percent yield is important in reducing the cost of every product produced through chemical processes. Percent yield equals actual yield over theoretical yield times 100. Okay, now to test your knowledge of what you just read, which of the following is the correct mole ratio for the following equation? 2 moles of aluminum plus 3 moles of bromine yields 2 moles of aluminum bromide. Now, you might want to pause the video here in order to think about this before the answer is revealed. The answer is B, 3 moles of bromine to 2 moles of aluminum. chemical reaction equation must be blank in order to make stoichiometric calculations. Is it A, measured, B, controlled, C, balanced, or D, produced? The answer is C, balanced. How many moles of carbon dioxide will be produced in the following reaction if the initial amount of reactants was 0.50 moles? The reaction is 2 moles of sodium bicarbonate yield 1 mole of sodium oxalate plus carbon dioxide plus H2O. Is it A, 0.25, B, 0.3, C, 0.5, or D, 1.0? The answer is A, 0.25. The mass of the final product in a chemical reaction is based on what? A, the amount of excess reactant, B, the amount of limiting reactant, C, the presence of a catalyst, D, the amount of O2 present. And the answer is B, the amount of limiting reactant. What is the excess reactant in the following reaction if you start with 50 grams of each reactant? Now you definitely want to pause this one and figure this one out before the answer is revealed. The chemical equation is P4, okay, phosphorus, plus 5 moles of oxygen yield 1 mole of tetraphosphorus decaoxide. And I recommend that you pause and try to figure this out and go back and look at the explanation of how to do it in order if you don't understand. Is the answer A, O2, B, P4, C, both are equal, or D, unable to determine from the information present? The answer is B, phosphorus. The amount of product that can be produced from a given amount of reactants based on stoichiometric calculations is A, actual yield, B, percent yield, C, theoretical yield, or D, stoichiometric yield. The answer is C, theoretical yield. If the theoretical yield of a chemical reaction that began with 50 grams of reactant is 25 grams of product, what is the percent yield if the actual yield is 22.0 grams of product? Is it A, 88%, B, 44%, C, 50%, or D, 97%? A, 88% is the answer. What law are all stoichiometric calculations based on? Is it A, the law of definite proportions, B, the law of conservation of mass, C, the law of conservation of energy, or D, none of the above? The answer is B, law of conservation of mass. The mole ratios can be determined only if what? A, all the reactants are present in equal amounts, B, the reactants do not have coefficients, C, the products do not have coefficients, or D, the equation is balanced. The answer is D, the equation is balanced. Now this one you're definitely going to want to pause the video. If the following reaction yields 5 moles of sodium gold cyanide, how many moles of gold were present as reactants? Assume all of the reactants are in excess. So 4 moles of gold plus 8 moles of sodium cyanide plus O2 plus water yield 4 moles of sodium gold cyanide plus 4 moles of sodium hydroxide. Is the answer A, 1, B, 4, C, 5, or D, 20? And the answer is C, 5. In the following reaction, how many moles of sodium cyanide are required to react with 5 moles of gold? It's the same reaction as the last problem. 4 moles of gold plus 8 moles of sodium cyanide plus oxygen plus 2 moles of water yield 4 moles of sodium gold cyanide plus 4 moles of sodium hydroxide. Is the answer A, 3, B, 5, C, 8, or D, 10? And the answer is D, 10. In the following reaction, what mass of sodium hydroxide is produced if 5 moles of sodium gold cyanide are also produced in the reaction? Once again, the same balanced equation. Is the answer A, 20 grams, B, 50 grams, C, 200 grams, or D, 400 grams? And the answer is C, 200 grams. The SI base unit of amount is A, the gram, B, the kilogram, C, the mole, or D, Avogadro's number? C, the mole, is the correct answer. Zinc reacts with iodine in a synthesis reaction. Zinc plus iodine yields zinc iodide. What is the theoretical yield of zinc iodide if 1.912 moles of zinc is used? Is it A, 6.103 grams, B, 61.03 grams, C, 610.3 grams, or D, 0.6103 grams? And the answer is C, 610.3 grams. In a chemical reaction, the statement that matter is neither created nor destroyed is based on what? A, the mole ratio, B, the law of conservation of mass, C, Avogadro's number, or D, the law of definite proportion? And the answer is B, law of conservation of mass. Which is not a product that must be produced in a double placement reaction? The blank is the maximum amount of product that can be produced from a given amount of reactant. Is it A, theoretical yield, B, actual yield, C, limiting reactant, or D, excess reactant? The answer is A, theoretical yield.